Torque. Torque gives turning effect. It is the turning effect of a force. Torque is the turning effect of a force. It is an axial vector or pseudo vector. Its magnitude is given by force multiplied by perpendicular distance from axis of rotation. Its magnitude is given by force multiplied by perpendicular distance from axis of rotation. Tau is the torque, that is equal to force F in the figure multiplied by r sin theta, that is the perpendicular distance. So torque magnitude is F into r sin theta. Actually, torque is defined in terms of cross product. Torque is a vector quantity, force is a vector, and position vector r bar is also a vector. So torque is the cross product of position vector r bar and the force vector F bar. Torque is the cross product of position vector r bar and force vector F bar. Its magnitude is Rf sin theta. The torque will be 0 if theta is 0 or 180. The unit of torque is Newton meter. So we can apply cross product for finding torque. Torque is a vector and it is the cross product of position vector and force vector. The relation between linear velocity and angular velocity can be expressed as a cross product. Here we come across three vectors: velocity vector, angular velocity vector, and position vector. To understand this, let us consider the plane OXOY is a horizontal plane. Imagine OXOY is a horizontal plane and OZ is perpendicular at the origin. Then consider a point particle P which is rotating in a horizontal circle at some height. The position vector of this particle P is OP bar or R bar. The position vector of this particle is R bar OP bar. And the angular velocity of this vector omega bar lies along OM, along z axis. Angular velocity lies along OM z axis. And the linear velocity of this particle will be tangential to the circular path. V bar is tangential to the circular path at P. R bar and omega bar, they lie in a vertical plane. The relation between these three vectors is V bar is equal to omega bar cross R bar. V bar is equal to omega bar cross R bar. Omega bar and R bar, they are vertical, so they lie in a vertical plane. And V bar will be in a horizontal plane, so it will be perpendicular to the plane contained by omega bar and R bar. So this is the relation between linear velocity and angular velocity. The relation between linear velocity and angular velocity can be expressed as the cross product. It is given by V bar is equal to omega bar cross R bar. In scalar form, we write this as V is equal to R omega, that is scalar form. Angular momentum can also be written as a cross product of position vector and momentum vector. See, in the figure, OXOY represent a horizontal plane in which a circle is given of mass m with a velocity v. So its linear momentum will be mv bar, that is along v bar. This is momentum vector. And position vector is from O to m, that is position vector r bar. And the angular momentum vector is L bar. It is perpendicular to the plane contained by OX and OY. It is along z axis. So angular momentum L bar is equal to R bar cross P bar, where R bar is position vector and P bar is momentum vector. So angular momentum can be written as the cross product of position vector and momentum vector. The magnitude is given by mvr sin theta. The perpendicular distance becomes r sin theta and momentum is magnitude is mv, hence it becomes mv into r sin theta.